Welcome back to the shop. This video is going to be covering the engine management system of the modern day motocross dirt bike, as well as the charging system and all the electronics that make the spark, run the fuel injector, fuel pump, the ECU, CDI, all the electronics on our modern day bikes. Now, we're going to be getting to the 4-strokes with the fuel injection, electric start, and all that. But before we get there, we have to go back to the basics. I'm going to start in the earlier years of basically the 2-strokes. This video will be in 2 parts. I'm going to get as far as I can on part 1, and then I'll pick up where I left off in part 2. And this will help the guys that have no clue on this, or are just getting into this and they don't really know any of these parts. If we start with the more basic 2-stroke, and then we're going to build on it through the years as they started adding parts to it, and then went to 4 strokes and added more electronics and more parts, and we'll walk through that as we go through it, and then we're going to piece this all together, as well as discuss what each one of these parts do when they fail, like on the modern day 4 strokes. And the hopes of this video is to help you better understand the system, so if you have an issue with yours, you'll be more educated and up to the task to be able to diagnose it and figure out what's going on. But for you to be able to do that, you have to understand the system. Yes, it's good to have the manual, and we need the manual, and we will be looking in the manual, but there's some things that are kind of left out in manuals, or it's gray, or they just kind of expect you to know. And so the hopes in this video is to get some of you guys that aren't up to speed on this stuff up to speed, so that you can diagnose your bike, figure out what's going on, and keep it out there, keep it going on the track. So before we move on to the modern day 4-stroke with the push button start, fuel injection, and maps you can connect with your phone, we have to start with the basic 2-stroke. Now this 2019 YZ125 right here, well, it uses pretty much the same electronics as they've been using since the early 80s. This bike doesn't really have anything extra on it since they've been using since the early 80s. I'm not going to go as far back as the 70s when they were using points, physical, actual metal points to make the spark. I'm not going to go that far back. I'm just going to go back to the early 80s, and this bike is going to be a good example for that because they haven't changed it any since the early 80s as far as the electronics are concerned. So first, back in the 70s, they had the point system that had some metal points that would make contact, and that would initiate the spark through the coil. It did not have like a computer or a brain or a CDI, as they call it. Starting in the early 80s, they moved to the CDI system. The CDI stands for capacitor discharge ignition, and you can see the little CDI box right there. Now later on, as this system became more complicated, and with fuel injections and stuff, it turned into an ECU. So when it's a CDI, it mainly just controls the spark. It's a computer, but it mainly only controls the spark. As they started adding other tasks on the system, it started to actually become a computer. It's multitasking, and that's when it turned into an ECU. And the ECU stands for Engine Control Unit. Some people call them PCMs, some people call them ECMs, but you know, it's all the same stuff for the most part. So on this more basic system of this YZ125 right here, which is the same system since the early 80s, you don't have much to it really. If we come to this right here, you'll see we have a stator coil, and the pickup will be right here on the coil. We'll talk about that a little bit more in a minute. We have the flywheel, we have the CDI, that's the computer right there we were just talking about, the ignition coil, and then of course you'll have like a kill switch right here, and that's just a button you press to kill the bike. So we'll start where the electricity is generated. The power comes from the stator itself, these coils right here in the middle, and the flywheel has some magnets in it, and it's connected to the crank, and when it spins, well, here's a flywheel right here. When it spins, the magnetic polarities right here, they interact with the coils that are just on the stator underneath it, and that produces electricity. It then sends that electricity over to the CDI, and then the CDI waits to get a signal from this ignition pickup right here. Here's the ignition pickup right here. If we spin this flywheel right here, you see that high spot, this little metal tab right here that's on the flywheel itself. When that passes underneath this pickup, it senses that, and it tells the CDI, hey, we're at top dead center, or we're close to it, or wherever they have it programmed. It's usually right around just a hair before top dead center. They have it programmed to trigger that off. That tells the CDI that, hey, it's time to fire. And at that point, the CDI will trigger the ignition coil here to produce electricity to go to the spark plug and make a spark. And that's what causes the bike to run. Of course, we have the kill switch here. Some bikes do it differently than others. Some bikes actually short out the positive wire that goes to the coil. When you press the button, it shorts, or not shorts it out, it grounds it out, and that kills the spark, which will kill the bike. And some bikes just send the signal to the CDI to stop producing spark. But all the kill switch is 2 wires going to a button here, and when you press the button, it connects these 2 wires together. When you're not touching the button, it disconnects them, and it's open. And that's all a kill switch is. While we're on topic, a quick tip. Most bikes out there will run with the kill switch completely disconnected, and sometimes kill switches go bad and they will be making a contact the whole time. These 2 wires, they'll be connecting them together the whole time, even though the button's not being pressed and you won't have spark. You can test it by just disconnecting the kill switch and try and start the bike. If it starts up, you know you have a bad kill switch. But anyway, so the stator is basically just a generator. It just generates power. It's what it does. Now on these older bikes like this, they don't have a voltage regulator. The power is not being regulated. So at low RPMs or idle, they're only producing a low amount of current, a low amount of voltage and power. As the bike spins up and you start revving it out, they will produce more power. I'm sure you've seen it on some of your like mopeds and stuff like that, where you pull up to idle and the headlight becomes dim, and then you rev it and the headlight becomes brighter. But it's pretty much the same thing here with these. It's not a regulated system, so the voltage kind of varies throughout the RPMs. But it's not a big deal because the CDI is not sensitive to the voltage. It'll run a low voltage and it'll run on high voltage. There's a CDI for this bike right here. The computer system in that's pretty barbaric and basic. I don't know exactly how many bits it is, but on this bike right here, but all it has to do is control spark. It's probably not going to be much. And because this older system right here does not have a throttle position sensor, the ECU, the CDI does not know how much throttle you're giving it. It doesn't know how cold or hot it is outside. It doesn't know any of that. All it knows is how fast the motor is spinning because it's receiving the signal from the pickup right here. So all it knows is how fast the motor is spinning. The timing advancement and retarding, basically, you know, at certain RPMs it'll advance the timing, and at other RPMs it'll lower it a little bit, and that's programmed into the CDI. It only does that based on RPMs. It doesn't know how much throttle you're giving it. So the same RPMs at quarter throttle, you're going to get the same timing advancement you're going to get at full throttle if you're at the same RPMs. It's a pretty basic system, but it works. They do have aftermarket CDIs that you can buy, which allow you to program and change the timing advancement if you like. You know, that's out there. The beauty of these systems are they are pretty simple, pretty basic, and when something goes wrong, they're pretty easy to diagnose. If I have no spark on a bike like this, first thing I do is disconnect the kill switch and then see if I have spark. If I still don't have no spark, then I can assume, well, the kill switch wasn't bad, so I'll just reconnect that. And I'll check all the wires. You know, I'll pull the tank and seat off, check the wires, make sure everything's still bolted down, make sure the coil didn't come loose or anything like that. And as long as the ignition coil, which on this bike, here the ignition coil is right up in here. There it is. As long as the initial coil is still bolted down and everything's connected to it and all the wires look good, well, then I'll check the stator. Now, you can follow the manual, and you can use a multimeter, an ohm meter, and you can check the stator and the pickup coil. What I will say is a multimeter will tell you if a coil is bad, but it doesn't always tell you if the coil's good. Let me explain this a little deeper. This is the stator for a Banshee, and there's the pickup for it right there that signals to the CDI when to spark. But this is the stator part with the coils that actually produce the electricity. When you check the stator with the ohm meter by probing it right here and comparing the values to what the manual says should be normal, it might read fine, but when you put it in the bike, it still doesn't work. It still doesn't produce spark. And the reason being is because these individual coils right here the wiring has an insulator on it to keep one wire from making contact with another wire. They spray it with like this coating or whatever, and they don't make contact with each other. But sometimes that coating can come apart, can become brittle, and then now you have two wires here making contact or close to making contact. And it's fine when there's no when it's not creating any electricity, when it's not being used. You check it with the ohm meter and everything's fine. But once the flywheel starts spinning and it starts trying to produce electricity, now you'll have two of these wires right here, a little spark going from one to the other, and basically screwing it all up, and then the bike doesn't produce spark. So just because it tests good with a ohm meter doesn't mean it is good. But if it tests bad with the ohm meter, you can be sure it's bad. And that's why I still test them with the ohm meter. But if they test good, doesn't mean it's good. But if it tests bad, I know it's bad. So if I have no spark, I'll test the stator, and I'll test the ignition coil with the ohm meter. Again, in the manual, in your owner's manual or service manual, it'll tell you how to test the ignition coil with the ohm meter and what values you should read. And while you're probing the stator to make sure that it's good or bad, checking it with the ohm meter, you'll also be probing the pickup coil. These do go bad, and as long as it measures within the proper ohms or resistance that the manual says that it should read, typically they're fine. If it doesn't, then you need to replace it, because that might be why you have no spark, if that's not good. You should also check the spark plug wire going to the cap. And on these two strokes, please, first thing you always do is try a new spark plug, obviously. But anyway, if the coil tests good and the stator tests good, why is it not making spark? Well, remember I mentioned sometimes a stator can test good but not be good. So now you're just gonna have to try a different stator. You're gonna have to buy a new one or borrow your friends or whatever. Try a different stator. If it still doesn't produce spark, then replace the CDI, and that'll usually do the trick. Now that's assuming all your wires are good. You know, if you can check all the wires first. Make sure you didn't get like a broken wire somewhere in the system, that the insulation is still covering it, so you think it's good, it looks good, but maybe it's not good on the inside. You can test that first with the ohm meter and go that route, or you can just say, hey, this harness looks good, let me just go ahead and buy ECU and give it a shot. The ECUs, the CDIs, the CDIs, there's no way to test these, right? The manual will usually walk you through checking the stator, checking the coil, checking the harness, and then it says, if all that looks good, just replace the CDI. That's what they say. So that's where I'm at pretty much with these simple bikes. Okay, now we're going to step out of the early 80s and step into the late 90s. We were all still on two strokes, but now we're using a 8-bit ignition system. The CDI is now 8-bit, has more power. And why did they give it a stronger CDI with more processing power? Well, because they've added a few electronics to the bike over the old system that pretty much just had an ignition coil, a stator, a pickup, and a CDI. Well, now it has a throttle position sensor and also a power jet. So the throttle position sensor is right here, right up here on the back of the carburetor right here, and all that's doing is telling the CDI how much throttle you're giving. Now, if you're more interested in the power jet and the throttle position sensor on these YZ250s and the YZ125, the new one from 2022 to current, check down in the description. I have a link where I walk through the whole power jet system, diagnosing it, also showing it how it works. I just geeked out on the power jet system and the throttle and the TPS, the throttle position sensor, on these Yamaha two-strokes. But anyway, they also added the power jet, which is right over here, and that started in, I believe it was around the late 90s on a lot of these two-strokes. They started adding the like 99, like really late 90s. They started adding the throttle position sensor and a power jet. The addition of the throttle position sensor now allows the CDI to have more of a mapping for the ignition advance. So now at a quarter throttle, it can run a slightly different ignition advance, spark advance, compared to full throttle. It'll run a different one there because now it knows how much throttle you're giving it. So the They still call them a CDI at this point. It's not quite to an ECU level, but now it has two inputs coming in. One input is how fast the motor's spinning based on what is seen at the stator, the pickup on the stator, the pickup coil telling it when it's at top dead center, so it knows the engine RPMs. But now it also knows the throttle position, how much throttle you're giving it. The advantage of that was it allowed them to change the timing curve based on the amount of throttle, so they were able to give you more throttle control. The rear wheel seemed to follow your hand a little bit better. It wasn't where, like the older bikes were kind of like, as soon as you cracked the throttle open, once it climbed up in the pipe, they just became pretty uncontrollable. Well, now they're more controllable with this throttle position sensor, and that's a good thing. But they also use that throttle position sensor to control the power jet, and like I said, if you check down the description, it'll be linked to that video. But they needed that to control this power jet right here, to know when to open up to let an extra amount of fuel in to make the motor run a little bit richer, and when to shut it down to cause the motor to run a little bit leaner. But just like the older system they used since the early 80s, the voltage does vary based on the RPMs. That stator will produce very little electricity at idle, and quite a bit more at its top revs, which you'll see in the video of the throttle position sensor. If you watch it, I had a test light hooked up to the electrical system on this. You'll see how it barely produced enough power to light up the test light at idle, but man, as soon as you got off idle, that light got bright. But the CDI, just like the old bike, is capable of running on a wide range of voltage, and it was just fine. Then in some of the later years on the two strokes, they started adding a gear selection sensor down here. Now on this YZ250, it only really tells the computer if you're in neutral or if you're not in neutral. I don't know what they added it for. I've heard rumors that it was to help lower the noise, the volume, the exhaust sound in neutral, so that it helps you pass sound tests. I don't really know. I know it definitely will shut down the power jet when you're neutral. If you watch the power jet video, you'll see how I discovered that. But they started adding that, oh man, I don't know what year. I think around 2011 for the American models, they started adding the gear selection sensor on the basic, two-stroke dirt bikes. Moving into the future, the four-strokes. Well, the first modern day four-stroke motocross bike was a YZ400F. This was in 1998. And the CRF 450R, and that was in 2002. All of these early four-strokes that were carbureted, all the carbureted ones pretty much had the same system, which was very similar to this two-strokes that we just spoke about. A stator coil with a ignition pickup on it, the flywheel, a CDI, an ignition coil, and a throttle position sensor. Beavis. Now I currently don't have one of these here right now to show you, so I'm just going to kind of use this 2025 YZ250F here. Let's just pretend this is one of the early four-strokes that were carbureted. Alright, the early four-strokes that were carbureted were much like my YZ250 that I showed you right there with the throttle position sensor on the carburetor, but it did not have a power jet. The four-strokes really don't need a power jet on the carburetor. So they didn't have it, but they did have a throttle position sensor. The only thing that throttle position sensor did on the carbureted four-strokes before they went fuel injection was tell the ignition how much throttle you're giving it, so it can cater the ignition advancement to the amount of throttle you're giving it. And that was really the only input the CDI would receive on them bikes, besides the engine RPMs at the ignition pickup. Just much like the YZ250 two-stroke I just showed you, it received two inputs, which was the ignition pickup, letting know the RPMs, and the throttle position sensor. Otherwise, it's pretty much the same system as the YZ250 that I just showed you a minute ago. And for the four-strokes, carbureted, all the same stuff that I just spoke about applies. Just because a stator tests good with the ohm meter doesn't mean it's good. The ohm meter will only tell you if it is really bad, but it won't tell you if it's good. The kill switch, if that acts up, you might not it might not spark. You can try disconnecting the kill switch. You see if you get spark. It's all the same stuff, just like the YZ250 and the YZ125 that I just showed you. Okay, stepping into the future a little bit more. 2009. A lot of your bikes started going to fuel injection in 2009. The CRF 450R did, as well as the RMZ 450, if I remember correctly. I believe the CRF 250R went to fuel injection in 2010. Pretty much by 2011, I think almost all your bikes, 250F and 450s, were fuel injection, except for the YZ 250F, which stuck around with the carburetor for quite a few years. I think all the way till 2013 it stuck with the carburetor. But these bikes were still kickstart bikes, and they did not have a battery yet. However, the system was already put together on the first fuel injection motocross bikes as if it had a battery, so to say. They were now running on a pretty consistent 12 to 13 volts. Pretty consistent. Because with the fuel injection system, it now needs a pretty consistent voltage. It now has like strategies and maps. It's paying attention to the air temperature that's going into the motors, paying attention to the coolant temperature. It's paying attention to a lot more stuff to choose the proper air-fuel ratio, as well as the ignition timing for the environment and for the conditions the bike is under. So for the math to be correct, they needed a more consistent voltage, much like our cars. So they run on about 12 to 13 volts, and it's the same thing though. Otherwise, it still has a stator. Let's pretend this is a carbureted 450 right here, or 250F. It will still have a stator generator, same thing, but now it has a voltage regulator. This little thing right here looks like a car amplifier with the cooling fins on it. Some bikes are up here, some bikes are underneath the seat. You can find them anywhere on the bike. Some bikes are down here, like the CRF 450s of them years. But what they did is they ran the coils for the stator first to the voltage regulator, rectifier, some people call it, right here. And then it would take the AC voltage, come from here, convert it to a DC at about 12 or 13 volts, I should say. It runs about 13 volts, so they can charge the battery while it's running. So you'll have the wires that come from here going to the voltage regulator, and then you'll have two wires coming out, and that will supply the voltage to run the power grid. And we're going to talk about that a little bit more in a minute, because that's pretty important when it's time to diagnose these bikes. Beavis is to understand that there is a power grid going on, and the power grid goes to the capacitor, or the condenser, the fuel pump, and the CDI to light everything up. Now, the interesting thing about these early systems starting in 2009, the fuel injection systems, is, like I said, it's pretty much the same system that they run now with a battery and electric start. And you'll be able to tap into the system with just a motorcycle battery, 12-volt battery, or even a car 12-volt battery, and light up the whole system. It runs on the same voltage, and it's pretty much the same system. It just doesn't have the electric start yet. But one of the cool things about these ignition systems that now have a not a CDI anymore, but an ECU, because now it's doing multiple things, so it's a computer. One of the great things about them is they can self-diagnose themselves for the most part. They give you trouble codes, much like our cars when a check engine light comes on, and we scan it for codes, and we get a code, and it tells us where the problem lies, or at least what the computer's seeing, what area is not working right, and then we know to head to that direction. On these bikes, every bike's a little different. Some of these bikes have a check engine light, or a light that you'll see when you start the bike up, light up, and then it'll shut off after the bike starts up. Well, if that starts flashing at you codes, well, you know you got a code. For these newer YZs, and even the kickstart models, for the kickstart models, you can connect the handheld tuner to it and pull trouble codes, and you can go to your manual. We're gonna do that a little bit in the video. I'm gonna show you how to go to your manual and chase down trouble codes and figure out where to go with that. But you can read the trouble codes that's stored on the ECU and chase down your problem. The KTMs have what they call a hey Beavis. Okay. I got my broom there. He knows what that means. He knows that means don't mess with me. All right, these KTM bikes, they have a FI light. You see that little light right up? Let me get my forehead light on it there. See where it says FI right here? That's the FI light, and I believe that stands for fuel injection. But that light will flash codes to you, let you know the trouble code, and then you can look in the manual, or you can just Google. You can Google KTM code 12 or code 14, but if it flashes, and a long flash would be 10, and then 2 quick flashes would be 12, and then I'll do it again. Long flash, 10, 1, 2, that'd be 12. And then that's how they do it. They flash codes to you, and then you can go in the manual and see what trouble code that is and chase down your problem. Now on the newer Yamahas, they'll have this little light right in here, and that will light up when you first start up the bike and then shut off. But if that thing starts flashing or it stays on consistently, you're going to want to tap into it with your tuner app, your handheld. Use your cell phone and tap into the bike using the Yamaha tuner app, and then search up or check what your trouble codes are to see what you got going on. And of course, there are some bikes, a few out there, like the older KX450s, the fuel injection ones, that they don't actually have a light to flash codes for you. So, and I'll include a link in the description to this little write-up right here, but it tells you basically buy a 12-volt bulb, and it tells you where to tap it into to basically make your own check light to be able to chase down the trouble codes. It has trouble codes. It just doesn't have a light on the handlebars to flash them at you, so you have to add your own light. And because these are kickstart bikes, they don't have a battery, so it tells you basically how to connect a 12-volt battery to. Again, we're going to discuss all this. It's going to apply to a lot of different bikes, so stick around for that. So the self-diagnostic system on these modern-day fuel injection bikes was an addition that they added once they had the processing power of a real ECU, and it is a lifesaver in a lot of situations, because otherwise we would have to be checking every sensor and everything to figure out where the problem is at. Now, you know, we're going to talk about that a little bit more when we get into the diagnosing part of this video, but I will say the computer can't tell you exactly what the problem is. It only tells you what it is seeing. So I'll give you an example. On this bike right here, there is a air temperature sensor in the air box, and there's only 2 wires that connect to this sensor, and all it does is tell the ECU the temperature of the air that's going into the motor. Well, that ECU doesn't know if that sensor is reading right or wrong. The sensor might be telling the ECU that it's 50 degrees out when in reality it's 100 degrees, or it might be telling it's 100 degrees out when in reality it's only 50 degrees. It doesn't know. It doesn't have any other references to compare it to, so it really doesn't know. But it does know if the sensor is disconnected, because it's not getting a signal from that sensor anymore, or feedback from it. And it knows if it has a bad wire, because again, it doesn't get a feedback from it. So that's really all it knows for that sensor is that sensor sending feedback to me, or is it not? And if it's not, it's going to kick the code saying that, and it's going to tell you what it is. It's going to say, you know, open, or sensor not basically communicating with the ECU, and then you know to go digging in that direction. So that's where I'm kind of explaining that to let you know that the ECU with the trouble codes, it doesn't actually tell you exactly what's wrong. It's just telling you what the ECU is seeing, but it's definitely a huge clue for us, so we know what direction to head in to figure out what's going on. Without that, we'd have to check everything, and that would be so time consuming. Now, these systems started in 2009 when they went fuel injection to the current modern day greatest of the greatest motocross bikes are what they call a speed density system, as far as the type of fuel injection system it is. Now, in comparison, on our modern day cars, they use a mass airflow system. What a mass airflow system is, I'll start with that, is basically a sensor right here. This is my car. This is the intake track right here going into the motor. There's your air filter. The air travels in here, goes in the motor, and they put a mass airflow sensor right here. What the sensor does is it reports to the ECU how much air is going into the motor. They're very accurate, they're very quick responding, and it can use that to know if it needs to add more fuel or less fuel. It's right on the money and it's quick. But our modern day motocross bikes do not have a mass airflow sensor. So this ECU is not receiving any information. I'm sorry, ECU on this bike is back here somewhere. Anyway, this ECU is not receiving any input on how much air is actually going in the motor. What they do is from the factory, the engineers, they spend a lot of time on dynos, engine dynos and stuff, and they pretty much they program a predetermined amount of air that they expect the motor to be pumping through at each RPM and at each throttle opening, and based on what it's reading on the air intake temperature sensor, as well as a barometric pressure sensor letting you know it's at high altitude or low altitude. And they build what they call maps, and based on what RPMs it's at, what air temperature it's at, what they can move these maps around for the air fuel ratio to allow it to run richer or leaner. But otherwise, they don't really know how much air is coming in. So it's all predetermined and it's programmed into the maps. Pretty much, it's like solid maps that it doesn't have a mass airflow sensor that can read on the fly. It's all predetermined from the factory, and that's important to know, because when you start making engine changes, like okay, let me go back a little bit. On a car with the mass airflow sensor, if I put a free-flowing exhaust system on it and it started flowing more air through the whole motor, the mass airflow sensor is going to sense that more air is going through the motor, and it's going to add the appropriate amount of extra fuel for the amount of extra air that's going through the motor automatically. So it's not going to start running lean just because I put a free-flowing exhaust system on it. But these are different. If you put a free-flowing exhaust system on, it doesn't really know. It doesn't know that more air is going through the motor because the ECU doesn't receive that feedback, the input. And at that point, it'll run a little bit leaner. But, you know, we can tune them, and, you know, we can program these ECUs ourselves. But what I'm getting at is this is a speed density system. Right, from Google, speed density system is an engine management strategy that calculates the air intake by using manifold pressure and air intake temperature sensors instead of a mass airflow sensor. It is often used in boosted applications, which allow for flexible intake tubing and bypass valves. Well, that's, I guess, for cars. The term speed density typically refers to the operation of an engine using an estimation of airflow based on pressure, temperature, and some idea of the engine's volumetric efficiency. So basically, it's an estimate from the factory. But for these dirt bikes, that's fine, right? Because we don't need the air-fuel ratio to be exact all the time, because we're not looking to pass emissions or save the environment. No EPA stuff. These are strictly close course competition use only vehicles, right? Now, all the modern day motocross bikes that are fuel injection using the speed density system, they all share pretty much the same sensors and electronics, except the only difference is between the kick-starting models and the electric start models. Obviously, the electric starter is going to have a battery and an electric starter and a starter relay and a start button. But otherwise, they all share the same electronic sensors and things like that. We're going to run through that real quick just to flash through before we go a little bit further. You're going to have a gear selection sensor right down here. Most bikes are on this side by the sprocket. They will tell the ECU if you're in neutral for sure, and then at least first and second gear on most of these bikes. Some might even tell the computer if you're in third, fourth, or fifth, but other ones it won't tell if it's in third, fourth, or fifth. It only tells if it's in first and second. And once you're in third, fourth, or fifth, they'll receive no signal from this, which will let it know that you're obviously in third, fourth, or fifth. And then you're going to have a stator, obviously, with the pickup that we've been talking about all along in this video. You're going to have a voltage regulator, and that just regulates the voltage to about 13 volts. A fuel pump that is in the fuel tank. A engine coolant temperature sensor. Now, depending on the make and model, these sensors can be in a different location. Some of these sensors right here, the coolant temperature sensor can be on the back of the cylinder. Some can be on the front. They're in different places, but you get the idea. And then we also have a ignition coil right here, and that's what produces the spark for the spark plug. A intake air temperature sensor right here, and that's because the air box in this bike is up front, but that's where it's located at on these YZ250Fs. Give you a little example here, like this KTM 250S XF right here. The air intake temperature sensor is, or intake air temperature sensor is right in here because the air boot and air box is back here. So you're going to find it in the air boot area usually. And their coolant temperature sensor is right here on the left side of the motor. And then on the throttle body, you'll have a fuel injector. And you can tell that it's a fuel injector because that's where the fuel line connects to it. And then right here, you're going to have this sensor right here. And it's basically it's a MAP sensor. It's a manifold absolute pressure sensor. You can tell which one that is on a lot of bikes because they'll have a vacuum hose, a rubber hose going from the bottom of the sensor into the side of the throttle body right here. And what that's sensing is the engine vacuum. So when you close the throttle here, there's going to be an engine vacuum below the throttle blade between the intake valves and the throttle body, throttle blade, and it's sensing that as the throttle's closed or as you start cracking it open. Obviously, once you go full throttle and there's a straight flow, then the manifold vacuum drops to about atmosphere pressure. But if I'm not mistaken, this is also used for the ECU to calculate the general atmosphere pressure, so it can calculate your elevation. So if you're high elevation and you're under lower pressure, it's going to be able to figure that out and know that you are and run a leaner mixture. And if you're at low, like sea level, it's going to sense the higher pressure and it'll run the bike a little bit richer to compensate for that. Now let me squeeze back over here. Then you have on the side of the throttle body here, you have a throttle position sensor, and that basically just tells the ECU how much throttle you're giving it. Coming back over here to this KTM, you'll see the throttle position sensor is actually on the left side of the throttle body right here. So, you know, there are different bikes going to have them in different locations, but if it's a speed density system, which all these modern day 4-stroke fuel injection bikes are, they're going to have the same sensors. And like this one, the fuel injector is actually on the bottom of the throttle body. And then all of your speed density dirt bikes that are kickstart and do not have a battery will have what they call a condenser. It's basically a big capacitor. Here's one right up in here on this KTM. Some with a battery, your electric start bike, some of them will still have a condenser and some won't. But when it comes to the kickstarting bikes, they all have it. And here's what that little bugger looks like right here. The reason they have these on the kickstarting bikes is to store power, electricity in the middle of the kicks, because the stator is only going to produce power while the motor's actually spinning. So when you're kicking it, you're only spinning it, and it spins a little bit. Next kick you kick, spins a little bit. But in between them kicks, it wants to store some electricity so that it can keep the ECU alive, it can keep the fuel pump going, and that kind of stuff. It kind of primes the electrical system of the bike. And so that's what these are. They're basically a capacitor or like a battery, a short-lived battery, but they call them a condenser. They have them on all the kickstart bikes that are fuel injection, and they still use them on some of the fuel injection bikes that are battery powered for whatever reason. I haven't quite figured out why they do, but on some of them they do. And we're going to be talking about this thing a little bit later in the video, because this is a pretty important area of the bike. If it is a kickstarting bike, when it's time to diagnose electrical issues, this will allow us to tap into the power grid of the bike and light the whole system up, even though the bike's not running, as if it had a battery, so we can diagnose it, get trouble codes, that kind of stuff. But we'll get to that a little bit later. On the wire harness, you will run into little boxes like this, fusible links, stuff like that. This little box is basically a diode that lets power go one way and not the other. Them typically don't fail, but sometimes the connections can become bad, or if your bike has corrosion issues, the terminal in here can corrode and break. So they're good to check out, but otherwise I typically don't find them bad. Besides, I just find them broken. All these fuel injection bikes will have a tip-over sensor of some type. Some are built into the ECU, and some are actually a standalone or separate from the ECU. Like this is a tip-over sensor for RMZ 450 and 250F. You also find some of these on the KXs. You'll notice it has a upper right here. So when you mount it on the bike, that up is supposed to be faced up, obviously, because that's how it knows if the bike tipped over or whatever. On the bikes that have a separate sensor that's not built into the ECU, you'll often find it up here, just behind the front neck of the frame, right over here, underneath the gas tank, around the ignition coil area. That's a popular place for like the KX and the RMZ to put them. I do know the YZs, the 450s and the 250Fs, it is built into the ECU. The ECU on this bike is down here, but some of the YZs will have them, you know, like right over here or whatever. But that's important to know, because if you're working on a bike and you have like the ECU not in its proper place, let's say you have it hanging over the side of the frame but it's connected, and you're trying to diagnose the bike, you're starting it up and trying to figure out what's going on, and then the bike dies after 10 seconds, you're like, huh, it's probably because the ECU is sitting on its side and it's not upright the way it's supposed to be. Or if it's on the back like this bike, they sit flat. You have to have it in the proper position that it is supposed to be on the bike, or it could trigger the tip over. Now the tip over time delay or whatever, where it shuts off the bike, is usually about 10 seconds on most bikes. So if you lay the bike over and the sensor is now on its side, you know, because the whole bike's laid over, in about 10 seconds it will shut off the bike. They have to do that on the fuel injection bikes because they can run on their side for a really long time. As long as there's enough fuel in that gas tank for the fuel pump to receive its fuel as it's laying on the side, that bike's just going to continue to run and run and run. And the problem with the bike laying on its side running it is now the motor is also on its side, and the oil pickup is not picking up oil anymore. It's not submerging oil anymore, so now you're running your motor drive oil in a lot of critical areas where it needs oil. That was not a concern on the previous carbureted 4-stroke bikes, because carburetors don't do very well running sitting on their side. They won't run very long usually and they'll die. So they didn't worry about that on the carbureted bikes. But once they went fuel injection, if you have enough gas in the tank, they can sit there and run indefinitely on the side until the motor basically takes a dump. So if you have an issue where your bike's only running 10 seconds and shutting down over and over again, check your ECU, make sure it's sitting in the right place. Or if you have a tip over sensor, make sure that is faced the proper way with upper face up. And then again, it could just be a bad sensor. Maybe try a different sensor. And lastly, an ECU. And this, on this YZ250F, it's hidden back here. But it looks the same thing as like on your 2-stroke bikes. It looks just like that, maybe just a little bit bigger and with a few more wires connected to it, because obviously it has more sensors and electronics going on. And of course, we can't forget that they're going to have a kill switch, obviously, and usually a check engine light on a lot of your models, or some type of light that can indicate if you have a fault code or not, or if the bike's overheating. It might just stay on the whole time. But yeah, that's pretty much all the sensors and electronics for the kick starting. Now stick around, wake up! We're gonna get to each individual sensor and what they do, and how when they fail, what they do when they fail, and how they all work together. But we have to finish this evolution of how we got to where we are today. So we're on the first fuel injection bikes that were still Kickstarter. Now they added electric start. Well, here's the interesting thing. To add electric start wasn't really difficult. Like I said, it's the same. They have a voltage regulator now, and it's running on 13 volts, and it has a power grid and electronic fuel pump and all that. All they had to do was add a starter motor, a starter clutch, and a battery, and that's all they did. Now, there are some brands like Honda that also added in the ECU some protective measures. Now they have electric start. So, and we'll get to that a little bit later when it comes to the diagnosing part, but that throws a lot of mechanics curveballs, and I got like 3 videos covering the starter issues with the Hondas. Because of their protection system, it throws mechanics curveballs. And we'll get there. But yeah, that's all they did was add a battery and a starter and a starter clutch, and wow, we got electric start now. But it was still a speed. It's still a speed density system, and it still has the same exact sensors and the same stuff going on as the kickstarting bikes. They really didn't add anything else since the kickstarting bikes besides that. Oh, and a starter relay for the starter motor. These electric start bikes, they will have a starter button, obviously, a battery, a starter relay, and a starter motor. And now because they have a battery, you're going to find that some of these bikes that you can have a handheld, you can use your cell phone to tune the bike, to tap into the computer system of the bike. They'll have this little box right here like these Yamahas do, and some of the other brands might have these boxes, and that is the communicator box. It is what does the Wi-Fi communication to your cell phone. You often have to access this box, find it and access it to get the serial number off of it. So the first time that you try to connect to it with your phone, it's going to ask for the serial number, and that's where you find it, is on that box. But anyway, the starter relay. Alright, so we have the main power positive wire right here, and that will go directly to the starter relay, because the starter relay does a few things. It's kind of the fuse box as well as the starter relay. So there are two fuses on most of your starter relays. One is just a spare fuse in case you blow a fuse on the trail, and the other is the fuse that it actually uses. There'll be a fuse on this side, and there's a fuse on the other side over there, which is usually your spare fuse. So from here, the main power goes right here, and it goes through the fuse, and then to light up the whole power grid of the bike. And then you'll also have the larger power wire coming off the starter relay, and that goes directly to the starter motor. Now, this fuse right here can be blown pretty easily if you accidentally connect your battery up backwards. If you get the polarity wrong on your battery, it's gonna pop that fuse right away. That's what that's there for. Usually, you get the battery connection right, put in a good fuse, and you'll be good. It didn't hurt anything. But that's the main thing that's going to blow that fuse right there, is connecting the battery up backwards. So when you hit your starter button here, there's two ways that manufacturers set this up. Some send the signal of you pressing this button right here directly to the starter relay, and then the starter relay will make complete a connection between the main power wire and the power wire that goes to the starter motor to start the motor. Is how the Yamahas are set up. That's number 29 right here is the start button. So that's the black right here, that's the ground for the start button, and the blue is when you press the button, it'll complete the ground, and that will come over here to the starter relay. And when the starter relay receives that ground, it will now make a connection to the starter motor and start the bike. But at the same time, you'll see it intersects right here. This one goes to the ECU, so the ECU gets a signal that you're trying to start the bike, but it's going directly to the starter relay at the same time. Other bikes do it differently, like the Hondas, the CRFs. When you hit this starter button, it is only connected to the CDI, not the starter relay. And then the CDI will take that signal and send the power that it needs to start a relay to send the power to the starter motor. And Honda does that a little bit differently because they have a more sophisticated protection system in their starting system. And we're going to get to that a little bit later in the video on the Hondas and the protection that they have built into their system. But that's how the Hondas do it. But that's where getting familiar with these wire diagrams can definitely be your friend. Like if I scroll up here, let's see. If I scroll up all the way over here, it'll tell me the numbers of every part. Like we can see right there, number 10 is the starter relay, and number 29 is the start switch, so that's the start button. And then we can come down here back to our diagram. I like to use one that has the color, and you can see right there, 29, that's the start button, and then 10 right here, that's the starter relay. And 11 right there, that's the starter motor. So you can see the starter motor is connected directly to the starter relay. On most of your electric start bikes, they don't actually need the starter button pressed to light up the electronics, like the fuel pump, and to start producing spark. As soon as they sense the motor spinning right here at the pickup, no matter how long the bike's been sitting, it's always kind of paying attention to this. When it senses that motor spin at the pickup, it's going to light up the fuel pump, and the ECU will start producing spark. And the reason they do that is in case you have to push start the bike. Let's say your button broke mid-trail or whatever, and now you can't get it started. You can push start it. Or if you're riding the bike and it dies on you out of nowhere, but you're still rolling, you can just let out the clutch and bump start it. It'll fire up. It doesn't need the starter button pressed to start up and to light up the electronics on most of these fuel injection bikes. which is one of the reasons why you should disconnect your ground, your negative from your battery when you're working on your bike, especially like the motor area, because I've even had it where the fuel tank was off the bike, disconnected, the fuel line was disconnected, but the electrical connection was still on it. And I went to go pull this cap off right here, went to go spin the motor, and all out of nowhere it lit up the fuel pump and it goes shooting fuel across the shop. So, you know, when you're working on a motor, it's good to just disconnect the ground just to be safe. But anyway, back to the starter relay for a minute here. Because these starter relays do more than just a starter relay, but it's also technically your fuse box. There are 4 normal size wires, you know, right here. They're not the big power wire and the other big wire that goes to your starter motor, but you just your standard normal size wires right here. You can find all of your wire harness. And these are what, first off, when you press the button, the start button, the 2 of the wires are for that, and the other 2 wires are for the power and stuff that come off the fuses to power up the whole bike. On some models they might only use 3 wires connected to it, and some will use 4, like this one has 4 wires connected to it. But it's important to know that, because if you have an issue where you have a battery connected to the bike but there's just no life anywhere, you hit the start button, nothing happens, you spin the motor by hand, you don't hear the fuel pump turning on, this thing just doesn't have any electricity, electrical power. A lot of times it's going to be an issue up here. Either the fuse blew or you have a bad connection right here. The Hondas are real bad at that. They get a bad connection right here. You can sometimes all you have to do is just disconnect this, pull it off, and plug it back in, and out of nowhere it fixed it just because the connection got corroded or whatever. The Hondas are bad at that for whatever reason, but any bike can do it. If you don't have power in your system, this is always a good first place to check. And like with all these sensors, the starter relay can be located anywhere on the bike. Every model does it a little bit differently. Like the Hondas, a lot of times they're over here on this side, way down here. If you're having a hard time finding yours, just follow the power wire. It will take you right to the starter relay. So that's pretty much the evolution of the modern day motocross bike, how we got to where we are today as far as all the electronics on the bike. I'm going to stop right here and pick up where we left off on part 2, which I will have up next week. If it's already up, just check down in the description. You'll see a link for it. If it's not up yet, it will just say coming soon. Check back for that a little bit later if you're catching this video later on down the road. But anyway, in part 2, we're going to look at each individual electrical component and talk about each individual one a little bit more in detail about what they do specifically and what happens when they go bad. Some of the symptoms the bike will show when that part goes bad or acts up, to kind of help give you some clues for when it's time to diagnose your own bike. We'll be digging into the power grid of the system, and that's going to be mainly for the kickstart fuel injection bikes, because you know, since they don't have a battery, you have to be able to tap into the power grid and light the system up to get to read trouble codes or to diagnose the bike when you have electrical issues. We're going to look a little bit deeper into the trouble codes and how to use the manual with your trouble code that your bike is exhibiting to help you chase down the problem. And I'm sure I'm forgetting something, but I'll cover anything else I can come up with between now and then when I make the part 2 of this video next week. Alright, this weekend I'm taking out the YZ250 2-stroke. I'm going to Spider MX. Beavis! I was supposed to ride there last weekend, but rain, I didn't ride there last weekend. We went there for Dylan's gender reveal party. He's having a baby, and it's going to be a boy. But I went there for that, but I didn't bring my bike because it was supposed to be raining, and when I got there it was pouring down raining. I probably could have got a little bit of ride in it earlier on, but it is what it is. So I'm going to make up for it tomorrow, taking out my YZ250. Hey Beavis, you're making too much noise. I hope you guys got something out of this. Thanks for watching. If you like this kind of stuff, you know what to do. Click subscribe. I appreciate all my viewers, all my subscribers. I hope every single one of you guys have a great weekend of riding. Hope to see you out there. Catch you next week.